Hey guys, so this video is specifically on complex numbers or imaginary numbers. So the objective is still to simplify radicals, but now we're going to have to use a system called complex numbers or imaginary numbers. Because back in the day, when they tried to find the square root of negative 49, they couldn't do it because there's no square root that is a negative. So they had to invent a number system so they could analyze various situations using negative square roots. And that's where I came in. So I, it's also written as this. It's kind of like a hooked I, is the square root of negative 1. So what that does is allows us, instead of having a negative square root, we can just put the symbol I in there, and then we can start analyzing situations. Now, the reason why we analyze situations using I is because sometimes we get these situations where we have I squared, which turns out to be negative 1, or I to the fourth, which turns out to be 1. And they turn into real numbers. I to the third is negative I. It's I times I squared, which is I times negative 1, which is negative I. It's kind of a pattern that comes up when we're analyzing different phenomenon in nature, that a lot of times I squared and I to the fourth come up and we can start analyzing these things. Today, we're just going to do the basics, where if I give you the square root of negative 121, the first thing we do is we break it down into the square root of negative 1 times the square root of 121. Now, the square root of 121 is 11. The square root of negative 1 is I. So now, I have a simplified radical, 11i, and I'm done with that. Now, this I to the 85th uses that pattern of I to the first is I to the second is negative 1, I to the third is negative I, and I to the fourth is 1. I to the fifth kind of repeats that pattern. It goes I, a negative 1, negative I, and 1 again. So every block of 4, it starts repeating the pattern. So what we do is we look and go, okay, how many blocks of 4 go into 85? Or we just say, okay, what's 85 divided by 4? And we have to use long division for this. So we do, okay, how many times does 4 go into 8? Twice. How many times does 4 go into 5? Once. With a remainder of 1. Now that remainder tells me that I to the 85th is going to be the same pattern as I to the first. So really my answer is I. I can do this with any I value and kind of simplify it down with not huge exponents. So let's say I give you a problem I to the 78th. Well, I would take 78. Divide by 4. Okay, long division. Again, 4 goes into 7 once. I bring down the 8. 4 goes into 38 9 times. Now my remainder is 2. So my I to the 78th is really I squared, which is negative 1. I just have to remember that there's a pattern. There's blocks of 4. In this case, there were 21 blocks of 4. In this case, there are 19 blocks of 4. And then I can simplify down my i's with huge exponents. Most of the time, we're going to be spending our time practicing these types of problems. So, in this case, these are simplifying. They're not perfect squares. But we're going to use the same process that we did when simplifying radicals. The first step, though, is always to break this down into negative 1 times 48, or in this case, negative 1 times 63. It allows us to just look at this number, 48, and leave the negative 1 out there, because we know the square root of negative 1 is I. So we can just say it's I square roots of 48, and then just look, okay, how are we going to break down 48? Because now that negative 1 is gone, it's I. So I break down the 48 into 24 times 2, 6 times 4 times 2, 3 times 2 times 2 times 2 times 2. So now, and the I is still in front. So again, I'm just breaking these down. Now I look for pairs. So 2 2's come out. So 2 2's is 4. So it'd be 4I square roots of 3. And that's my simplified answer. In this case, again, I can take out that negative 1. That square root of negative 1. That's going to be my I. And now I break down 63. 9 times 7. I can break down the 9 into 3 times 3 times 7. There's still that I in front. I see the pair of 3's. The 3's come out. I square roots of 7. And that's my answer. Because the I is the square root of 1, I just pulled that out. I don't have to have it in the square root anymore. In these examples, we're going to be doing more operations with i's in the next class. But this is a very simple, just multiply these. So the first thing we do is we multiply the numbers. So negative 3 times 4 is negative 12. I times I is I squared. But if you remember from the pattern, I squared is really negative 1. So we get negative 12 times negative 1, which is 12. That's my final answer. We're going to be doing more problems like this next class. In this case, we have the 2 square roots. So what I want to do is I want to combine them into 1. But the trick is, and I had said this in simplifying radicals, I don't multiply them. So I combine them into 1, and I don't multiply them. And I start breaking them down. So negative 3 can be broken down into negative 1 times 3. Negative 15 can be broken down into negative 1 times 15. Now I can break down the 15 again. Into 3 times 5. Now I look for pairs. Okay? So what happens is I have a pair of negative 1's and I have a pair of 3's. So I can take out negative 1 and a 3, but I have to leave in the 5. So my true answer is negative 3 square roots of 5. Now you might be wondering, why didn't I just multiply these and make these positive? Well, what happens is I actually can't do this operation without i's. So the true mathematical way of doing this, and I'll just move this stuff over, is to separate the i's out. So then I can do operations with radicals. So this is really I square roots of 3 times I square roots of 15. And then I multiply them together, I get I squared square roots of 3 times 15. And now I can break this down into 3 times 5. I squared, if you remember, is negative 1. And now we got a pair of 3's, which is 3, and then I got the square root of 5. They come out to be the same answer. This is a little bit easier because you see actually the pairs of negative 1. Well, this way is technically more mathematically correct because I have to take the i's out first to be able to simplify the radicals. The other problem that I wanted to discuss was number 4, because these are just simplifying. This is an operation. So this operation, you'll notice that's 2 parentheses, and they're multiplying each other. So I have to use that double distributive property, where I do 2 times 2, which is 4. 2 times negative I is negative 2i. I do I times 2, which is plus 2i. And then positive I times negative I is negative I squared. What you should notice is the middle terms here cancel because the one's positive, one's negative. So I'm just left with 4 minus I squared. Again, this keeps repeating, but I squared is negative 1. So I substitute that in. I have 4 minus negative 1, though that turns into a plus plus, my answer is 5. Again, sometimes with those operations with imaginary numbers, I can actually analyze a situation and get a real number, 5. Okay, and I don't have those simplified radicals. Those are the answers to those practice problems, but make sure that you're actually showing me the work so you can get credit for this assignment. The last example that I'm going to show you is how to solve using square roots and those i's. Just like the previous problems that we were doing, we have to isolate the x squared. So a minus 5. I get x squared equals negative 5. To undo a square, I do the square root. But unlike in these situations where I'm just simplifying, this is an equation. So every time I'm solving an equation, I have to put the plus or minus piece. Remember, there's a positive answer and a negative answer. And in this case, it's a square root of a negative 5. So, in reality, this is negative 1 times 5. Well, I can't break down 5 anymore, but I know that the square root of negative 1 is I square root of 5. That is what x equals. So every time I have a square root of a negative number, I is on the outside. Another example of this is problems like number 5. So again, I would subtract 45, divide by 5, but now I take the square root. But every time I'm solving and I take the square root of both sides, I have to add in that positive or negative case. Now the square root of negative 9 is 3i. So that plus or minus means that x could be 3i or negative 3i. That plus or minus, remember, there's 2 answers to it. So in each one of these cases where we're actually solving, you actually have to put the plus or minus in front. It means that there's 2 answers. When it just says simplify, that means you just simplify down the number as best as possible. You don't need that plus or minus piece. It's only when you're solving. Okay? Please complete the rest of these problems and check your answers. Thank you.